check, right? Voluntarily I on here. Okay, so take down the question first. Train the auto-associative network. Train the auto-associative network for input vector -1, 1, 1, 1. This is our input vector because we don't consider the output over here since input as well as output will be size will be same. Train the auto-associative network for input vector -1, 1, 1 and also test the network. Also test the network for the same input vector. For the same input vector. That is the first half of the problem. Test the network for any one. Test the network for any one missing entry. Any one missing entry and 2 mistaken entries. 2 mistaken entries in the test vector. So what is the question given over here? You are given an input vector. You are going to train your model first. After training, you are going to test your model with the same input vector. Okay? So once you test with the same input vector, definitely it should be correct. It should be able to recognize the input. Next, what we are going to do, we are going to test with the input vector where there will be one mistake. And then we are going to take an input where 2 mistakes in the input vector. So we are going to see the difference. Clear? So how we are going to solve this problem? We are going to follow outer product rule. Outer product rule. When you do so, how the weight gets updated, how the weight matrix will get updated. I have taken only one input vector. Suppose if you are taking a list of input vectors like the problem which we had solved earlier where we had S1, S2, S3, S4. It is a matrix. But here we are taking only one input vector. The simplest example we are taking. So when we are taking this input vector, how are we going to update the weight? The formula for that is sum of transpose of the vector into the same. Okay? So the input is considered like this. So it is the simplest multiplication. Please do complete and give me the answer. Multiply both of them. No need any calculator here. Multiply both and give me the answer. It will be of 4 by 4 matrix. How do you multiply? 1 with all this. Right? So if you multiply, so -1 into -1 plus 1, -1 into +1 will be -1, -1, -1. So second value you are taking, multiply, so it will be -1, 1, 1, 1. Similarly, other 2 rows also. -1, 1, 1, 1. Any doubt in this? So we have just calculated the weight. Now we are going to testing the network with the same input vector. Same input vector. So we have just model. Now we are going to test with the correct input vector. So definitely my model should recognize the testing value. Okay. So I am going to test with the same. How do I test this? Y in J, which will be tested this formula you are having, x into just W only. Okay. So x into W, which is nothing but what is my x? which is 1, minus 1, minus 1, minus 1, minus 1, 1, 1, 1, minus 1. Yeah. Now you please multiply and give me the answer. Multiply both of them because that is the formula to test. What is the value you are getting? Now it will be a vector only. It won't be any 4 by 4 matrix. How do you multiply that? Like this. No? So minus 1 into 1 will be minus 1 plus 1 into minus 1 again minus 1 plus 1 into minus 1 minus 1 plus 1 into minus 1 minus 1. So altogether it is. I am not getting any answer from my side. What is the value you are getting? Minus 4. You must get the value as minus 4. So complete the rest of the elements too. So now it will be this and this. What is the value? Rahul, any doubt? What is the value? Abhishek? 4. 4 is right. Continue. 4. So other 3 elements will be only 4. Now we are going to test. Now go back to your algorithm. See the testing algorithm last step. What is given over there? If the value is greater than 0. Test. You are testing the, we can say that applying activation. Applying activation function. What is the rule given over there? 3 conditions will be there. If it is greater than 0, it will be 1. If it is less than 0, it will be minus 1. So, by applying that activation function, you are getting the result as, you have that as the last step in the testing algorithm. Okay? So, there will be 3 conditions. If it is 0, it will be 0. If it is greater than 1, it will be plus 1. If it is less than 0, it will be minus 1. So, accordingly, I am getting the value as, for minus 4, it is minus 1. Plus 1, plus 1, plus 1. Okay, which is my input vector? Which is my input vector? So, my system is able to recognize the model. Recognize the model. Conclude this with, it is able to recognize the model. Any doubt here? Yes? Okay. So now we are going to take X as, with one mistake, I am going to take the input vector. I have modeled my model with the input minus 1, 1, 1, 1. Okay. But I am going to make a small change on this and I am going to check my model. Where I am going to make the change, instead of minus 1, I am going to give 0, 1, 1. 0, 1, 1. So now I am going to test the model. Training part is done. We are only testing with the various input. Okay. So this part we will not be repeating again. We will only do the testing part. So now the input is this. Please perform the testing steps. While J is equal to x into w, where x is equal to 0, 1, 1 and w is equal to so on. So perform multiplication, apply activation and tell me the answer. So finally you must get the response as this. Because I am trained my model to recognize only this input. So however I give the input, I am getting the result as this. My model is recognizing the input. Okay. So please follow the steps. Find out this value. Let us see whether my model recognizes my input or not. Are you able to follow? We trained our model. We tested with the same input. It worked well. Now we are testing with a different input. That slight variation on the input I have done, and I am going to test my model. Test and tell me. are wrong. Yeah. Now take the input as -1, -1, -1 and 1. This is the input vector I am taking now. -1, -1. These two entries, instead of giving positive value, I am giving it as negative value. Two mistaken entry I am testing with. I have trained my model to recognize this kind of input. And even in that, if there is a small mistake, it is able to recognize. Now I am trying with two mistakes in the input. Let us see what is happening. Okay? So same process. Take the input as -1, -1, -1, 1. Find out the value here. You cannot erase like this and write. You need to write separately. What is the value you are getting? By multiplying. Such a simple method. Why can't you do? I want everyone to do, each individual to do. Vijay, I want the answer from you. Multiply and give me the answer. Do it fast. Dhaneshwar, what is the answer? 0. So this will be -1. This will be +1. Again +1. -1. It will be 0. Next. Next. I expected answer from Vijay. What is the second value? Just a simple matrix multiplication. Tell me what is the answer? This needs to be multiplied with this and tell me. 0. -1 into -1 will be +1. -1 into -1 will be -1. -1 into +1 will be -1. 1 into 1 will be +1. So +2 -2 will be 0. Third element 0. Fourth element 0 only you are getting. Yes, fine. When you apply activation function over there, if it is 0, you get 0 only. Correct? Any doubt? Yes. Auto associative memory 0 and -1. அதுதான் ரூல் எழுதிருக்கீங்களா? Yes, fine. So then go back to the previous one. For the previous value, after applying activation function, what were you getting? There is no 0, so we didn't have any problem. There is no 0, we didn't have any problem. Now, when it is 0, it must be -1. So which means everything will be taken as -1. Correct? Everything will be -1, whereas the expected thing should be -1, 1, 1, 1. So my model will not be able to recognize this input. Okay? So this method will not recognize the input. This is how you have to conclude. Okay? Yeah, that rule please remember, you should have corrected before itself. Yeah? Any doubt? Clear? Okay. So this is how you need to solve any auto associative problem, because if you go with the head rule, it will be too lengthy. Somewhere you will forget the step. Okay? That's why follow this method. Shall we go with the next model? Hetero associative memory. The procedure will be almost the same. Only in the testing part, the condition will vary. Remaining all will be same. Okay? But here the input will be given in a different way because we need to exclusively give the output to. Size of the input and output will be different. Whereas in auto associative, size of input and output will be same. So anyone can taken. Always input will be taken. Whereas in hetero-associative, input size definitely will vary from output size. So the input will be given as with the name S, and the output will be given with the name T. Go through the procedure once for hetero-associative. Take down the question now. Train a hetero-associative network. Train a hetero-associative network to store the given bipolar input vector. To store the given bipolar input vector P is equal to T1, T2, T3. No, input vector will be S, no, sorry. Yes, S1, S2, S3 and S4 to the output vector. T is equal to T1, T2. Also test performance of network. Test performance of network with missing and mistaken data in the test vector. With missing and mistaken data in the test vector. Same as out of associative, we are going to solve one problem. So you must be given the input S1, S2, S3, S4 as well as T1, T2. This is how even we had a problem for hetero, but there we applied the Hessian rule. Okay, so we are going to see the problem with outer product rule. Take down the input, and for this the output would be of this. Okay, so next input, minus 1, minus 1, minus 1, 1. The output is 1 and minus 1. Minus 1, minus 1, 1, 1. Output is, I have taken 4 different input and the corresponding output. Please remember, pass it. Input as well as output will be same. So we were not given like this. Whereas in hetero-associative, input and output size may vary. Sometimes it may be equal, not always, but sometimes there will be a change in size. Similarly, you say there are 4 vectors in input, whereas only 2 in output. So we have taken 4 inputs over there. 4 inputs. Each has 4 elements are vectors. So various combinations, 1, minus 1, minus 1, minus 1. Now the output is minus 1 and 1. It is the predicted output. This is what I must get it as the output. Similarly, if the input is 1, 1, minus 1, minus 1, output must be minus 1, 1. And so on. Okay. So first step is we need to train our model. So this type of input is, we call it as bipolar. Bipolar set input is given. So now we are going to solve this solution to store bipolar vector pair. The weight matrix is same transpose of P into T of P. For the first pair, one by one we are going to do now. For the first pair, that is input and output, we need to train each and every input. Finally, you will get a weight matrix. So weight matrix row by row we are going to compute now. So it is for the first pair. It could be yes, I need to get W1, W2, W3, W4, then it becomes a weight matrix. Whereas in the earlier stage, we didn't have a matrix. We had only one input vector. So W1 is computed as same formula 1 minus 1 minus 1 minus 1 into, there we could multiply with the same, but here S and T, S and T, S and T, transpose of S and T, got it? Transpose of S, that's why I have taken like this, and then T, minus 1 and 1. Please multiply and give me the answer. It will be of 4 rows with 2 columns, correct? Like this now, we will do multiplication. So 1 into minus 1 plus 1 plus 1 plus 1. Similarly, second row, so 1 minus 1 minus 1 minus 1. Are you all getting this? So you must get W1 as minus 1 1 1 1 1 minus 1 minus 1 minus 1. See how I am multiplying? This is how first step and then second step. So now we have done for the first pair. First pair S and T. Similarly, we need to do for second pair, third pair, fourth pair. Okay. So take the second pair. For second pair. So S is 1 1 minus 1 minus 1 and T is equal to minus 1 and 1. Got it? So now using this we need to compute W2. W2 transpose of S 1 1 minus 1 minus 1 and then T minus 1 1. Right? So same way you need to multiply this. So you will be getting answer as minus 1 minus 1 plus 1 plus 1. Similarly, 1 1 minus 1 minus 1. Are you all taking this? For the second pair, W2 minus 1 minus 1 1 1 1 1 minus 1 minus 1. So please do complete for W3 and W4. Danishwaran Master. Third pair. Whether my model will recognize the given input or not. Clear? So please remember, this is the input, this is the weight matrix. The formula will be same. Formula will be same as your auto-associative memory for testing. Okay? And while applying activation function only, 3 different conditions will be followed. It is greater than 0, plus 1. Less than 0, minus 1. Equal to 0, 0 itself. Hetero-associative result is that. Testing. 3 cases are there, right? Yeah. Fine. So we will do now computing the net input. Computing net input. How do we do this? Y in 1, Y in 2. I am going to check 0, 1, 0, minus 1 with the matrix minus 4, minus 2, 2, 4. 4, 2, minus 2, minus 4. Multiply and give me the answer. This. Multiply and give me the answer. Dhanashri. I don't think you will get like this. On this. After this step, apply activation function. You know to apply activation function. If it is less than 0, the value will be minus 1. If it is greater than 0, the value will be plus 1. You have it in your algorithm. Testing algorithm says this rule. Accordingly, you are getting value as minus 1 and minus 2. What is your predicted result? What must be the predicted result? Minus 1 and 1, which I am predicting. So, the input x 0, 1, 0, minus 1 is recognized by my model. Clear? So, if I am getting the expected result out of this input, my model is able to recognize. Now, take another variation on the input. So I am going to make few more mistakes on it. So now the test vector is going to be x is equal to minus 1, 1, 1, minus 1. Minus 1, 1, 1, minus 1. So the actual input is 1, 1, minus 1, minus 1. Actual input vector is 1, 1, minus 1, minus 1. What is the output for this? Minus 1, 1. Same one I have taken, right? 1, 1, minus 1, minus 1. I must get the output as minus 1, 1. But I am having input as this. Now it's your turn to complete this. Your x is this. Minus 1, 1, 1, minus 1. And this is your weight matrix, which is perform the computation. Write clearly and perform the computation. Minus 1 into minus 4 will be 4. 1 into minus 2. Minus 1 into minus 2. Minus 2. So already you have 4. 4 minus 2 will be 2. 1 into 2. So now it is 0. Minus 1 into minus 4 plus 4. Minus 2 plus 2 minus 4. Yeah, you are getting value as 0. Next step. Minus 4 plus 2 minus 2 plus 4. You are getting output as 0, 0. But what is your predicted output? Minus 1 plus 1. But what is the output you have got it? 0, 0. So, my model is not accepting this input. That is the conclusion. Okay? So, what you understand from this, though you train your model with the fewer mistakes on some input vector, it is able to recognize. But some mistakes it is not able to recognize. Okay? So, you train your model with some images. Okay? When you are testing the image, when there is some minor errors like this blurry picture or pictures. It will not